So good afternoon and welcome to the third and final live session of my course Operation and Planning of Power Distribution System. So this is the final opportunity for the learners to interact with me. If you have any questions regarding the course content or regarding the assignment or regarding the syllabus of the particular course or anything else, you can share with me. To share with me, you can directly connect yourself in Microsoft Team. I think that team link was given to you, or you can write your query on the chat box of YouTube, or you can also join the Microsoft Team and can directly ask me the questions. Or there is a facility to write down your query in the chat box. That also you can do. I think one learner has joined, Yusuf, but your voice is not audible. You can write your query on the chat box. If you have any query regarding any particular topic, this is the last opportunity that you will get to clarify for me.
Can you just give a brief on swarm optimization, inertia based?
Okay, so yeah, so good afternoon, Yusuf. So yeah, so particle sum optimization is a kind of meta-heuristic optimization algorithm. Okay, so this meta-heuristic optimization algorithm, they work with some meta-heuristics, okay, some heuristic rules or heuristic ideas. So here, this particle sum optimization, the philosophy of the Barth-Floch or fixed schools are used to optimize certain engineering problems or any kind of mathematical problems. Okay, so Similar to all the meta-heuristic algorithm, this is a population based. That means there are two types of optimization approaches. One is point-to-point based search, another is population based search. In the population based search, a group of randomly generated solutions are iteratively updated to find out the best solution, which will be supposed to be the optimal solution. All right. So here you need to understand that this algorithm will start with some randomly chosen solution. Now, a group of randomly chosen solution is called population. Now, in a particular population, every solution can be a potential optimal solution. Now, what it is done that these solutions consist of a position and a velocity. Okay, so positions are updated with the velocity information in the next iteration. So in the next iteration, the position is updated with the previous iteration position plus the velocity. All right, and therefore you will get a new position, and corresponding to new position you will get new optimization objective, and it is termed as the fitness of the particular objective or particular problem. Okay, so now based upon this iterative process, there are some rules or some equations which are basically used to update the position and the velocity of the solution. Okay, and here we basically use two philosophy. One is a position is updated with the previous iteration position plus the velocity updatation with the this new population. Okay, now how this velocity is getting updated? This velocity is updated by with a strategy called cooperative strategy, where the best solution in terms of the fitness is identified, and all other particles will try to move towards the best solution obtained so far. And also there is another there are two ways, as I said, to update the velocity. One is by following the best solution. Another is by following the own best solution of that particular solution corresponding to the previous iterations. Okay, so this is how the velocity information is used to update the position of a solution. A position means here a position encodes the optimizing variable. Suppose if we have an optimization objective fx, where x is a n-dimensional vector. So here the position encodes the information of the x-dimensional vector or optimizing variables or variables. And fx stands for the functional mapping of this variable, and that is called fitness function. Okay, here in the meta-heuristic algorithm. So now in this way, actually, a group of randomly chosen solutions are updated with their this meta-heuristic rule, and then finally the best solution among all the solutions is identified. Now you are talking about the inertia weight. So inertia weight is just a multiplication factor which is multiplied the velocity, so that the velocity should not be extremely high or extremely low. Okay, so specifically an extremely high velocity means the particular solution would be outside of the boundary of the feasible solution after few iterations. So to restrict that, to restrict its velocity, the inertia weight is used. Okay, this is in brief the explanation of particle sum optimization, although the detailed explanation I mentioned in the course. If you have a specific query, you can go ahead and ask.
Thank you, sir.
Thank you, Yusuf. If anybody has any other query, you can go ahead and ask. So the idea of having this vertical sum optimization is to briefly, explain you that how the methodistic optimization algorithms work. Because for many of the engineering problems, the conventional optimization, mathematical rule-based optimization algorithms may not work. Okay, if the problem is non-convex, if the problem is non-linear. So therefore, how to solve those type of problems? So here we use some methodistic optimization algorithms. The advantage is that they can provide some solution, but the disadvantage is that there is no guarantee whether they give you an optimal solution or not. So that's what the thing is.
Sir, capacitor bank will not come in the distributed energy resources, is it?
No, distributed because capacitor bank is a kind of reactive power source. Okay, so they can provide reactive power, but they cannot provide any sort of energy. They are not energy resources. Okay, so capacitor bank will come under the reactive power sources, not distributed energy resources. Capacitor bank cannot provide you the active power or active power or energy impact. So any other query, any other question? Those who have joined online, on YouTube online, you can write your query or question on the chat box.
Sir, can you just explain the voltage control using active power injection?
Voltage control using active power.
Yeah, is there something like that?
Actually,
Injection
voltage is usually controlled with reactive power resources.
Yeah, by changing the excitation, is it?
Yeah, no. Here, voltage is basically controlling power distribution network either by using this OLTC, on-load tap changer of the substation transformer, or by placing capacitor bank. But in modern power system, specifically in smart grid domain, there are some other devices for providing the or for supporting the voltage. That comes under this volt-var control. So there is some module that I discussed at the end, last module, that is called volt-var control. So if you look at, you'll get the idea of it.
So can you just explain a little bit about the exam pattern?
Exam?
Yeah, exam pattern, the final exam.
Exam pattern, as I said many times, that it will be similar to the assignments. Assignment, you have seen that there would be some numerical question. There will be some questions where a comprehension would be given, and based upon the comprehension, some numerical problem will be asked to solve. For example, when you talk about the reliability, there are some indices like psi, 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 chi, chi, chi. So you have seen it. A table will be given which will represent the fault data for historical fault data for a few years or for a particular year, and then you will be asked to solve the indices like psi, psi, and all. So similarly, in whatever the question patterns we have seen in different assignment, the exam questions will be almost similar. Okay, so of course it will be multiple choice type of question, and it will be 100 marks, and so you can expect many questions, and all the questions will come from the different modules. Okay, some questions will be theoretical, and some question will be numerical. Pattern will be exactly similar to the assignments.
The numerical questions will be the type which we can solve by the online calculator. We don't have
yes.
much.
Yes. Your online calculator will be capable enough for solving the numerical problems.
Because some in assignment, some questions are there, some equation comes in the cube code equations, little bit harder. So I think it will not be coming something like that.
No, that means power x to the power y can be used there in the what we have in the screen computer, that screen calculator, that is a scientific calculator that will be appearing on your screen. You can solve it. The scientific calculator that will be given to you on the screen of the monitor, that will be capable enough for solving all the numerical problems. And numerical problems, the pattern will be almost similar to the what I discuss in the courses, in the course or in different modules or in different assignments.
Okay, so thank you. Around 50 to 60 questions.
Yes. From some module, you will see that theoretical questions will come similar to the assignment. From some module, only numerical questions will come. So if you follow the pattern of the assignment, the same thing will happen to be true in the exam also. So any other question from any other learner? those who have joined on YouTube online or YouTube live, you can write your query or question on the chat box. If you do not have any questions, I will conclude the online this live session. So any further query, you can write down on the chat box, or you can join Microsoft Team to interact with me. So if there is no further questions, let me thank all the learners, specifically those who have joined online today for enrolling this course. And I wish good luck to all of you for the session ending examination. Thank you. Thank you very much. Thank you again for enrolling this course.
Thank you, sir.
Okay.